Hello guys, this is Bismarck and welcome back to another session on Rxjava operators. Today, we'll be taking a look at combining operators used in Rxjava. For my previous tutorials, I had treated filtering operators in Rxjava, the various operators that are very useful and handy when it comes to using Rxjava. In this section or this segment, we like to treat combining operators in Rxjava. We are going to start off with zip operators. If you have been following keenly on these tutorials, you will see in my previous tutorial I have been using zip operator, but today I want to touch on it officially on how to use zip operators in Rxjava. Okay, and subsequently we'll be talking about the various combining operators, useful operators that you can use to help in your development, to make your development very easy. So what is a zip operator? Okay, zip operator is an operator in Rxjava that combines a mission of multiple observables through a specified function. And this is what I mean. Let me show you what I mean. So we have a marble here. Okay, so this is a zip marble in Rxjava, and these are the emissions. So we have the first emission and the second emission, and these emissions are being passed through a certain specified function, the zip. So what it does is as the definition went, it combines the emission of these multiple observables. Okay, so let's say the first item emitted from this first observable is 1. The second item from the second observable, the first item from the second observable is A. Since based on the specified function, now we are going to get this result 1A. Why? It is combining the function, but basically it depends on the function that you pass to it. So you can depend on your scenario that you are actually looking forward to. So, and one thing is, when it comes to observable, let me try to slide off this item. As you can see, sliding off this item, it goes like that. So you could see that the length or the number of items in the first observable is more than the number of items in the second observable. In the first observable, we could have something like 1. We could have something like 1 to up to 5. The number of items are 5. And the second item, the number of items are 4. When it happens like that, since always it has to come in pairs, not just pairs, it has to come in for every emission, it has to contain an item from each of the observables being applied. And this is what I mean. So here we have first observable and second observable. 1A, 2B will come, 3C, 4D. Okay, but the 5 doesn't have a companion or a partner in the second observable to emit. In such instance, it will ignore the 5. So one of the key notes that I have to take is always, if you want to expect the exact number from your observables as your result, then the length should be equal. The length of the items emitted should be equal. Great. So now let's come to the console and try to work some things out. Okay, so for example, we have, let's say, a list of students, and we want to know the scores got by each student. And this is what I mean. So let's try to create a student, and this is our students. We have Nat, Kelvin, Roxanne, and Cindy. So for example, we have these students, and let's try to create our scores. And this is our scores for the students. And as I said, they have the same length. They have the same number of items. Here, the number of lengths and number of data in the array is 4. And the number of data in this array is also 4. So we are going to expect a complete emission of these items. So how do we combine these observables? How do we combine these observables? I will show you something, but before that, let me try to comment this. I'll come back to it later on. So with this observable, now we can try to use zip with zip iterable. So these are all helper functions that are forms of zip operators. So we start off with observable dot zip. So let's try to zip the students and we zip the students, then we zip the score. So we combine these emissions. Then here we have to provide a function. So let's try to provide a function. So since we are having only two, so we can use by function. By function. And yes, here's a string. And what are we going to have? Okay, so let's try to use a string 2. Okay, and now we can subscribe. So system dot out print line. Okay, so should we run this? Let's try to get the subscription so that we can avoid this. Okay, so should we run this? We will notice that we are going to have Nat will have 20, Kevin will have 30, Roxanne will have 50, and Cindy will also have 60. So based on this function, so this is a function that will give us, the various transformation or the combination that we want. Okay, so we have a string, so we could do something like print dot format. Let's try to format them. Okay. Okay. And we have the string and the integer. Okay. So let's run this. Let's run this and see the output. And let's see if we are going to get what we are expecting. Exactly. So right now, this is one item, one observable, and this is another observable. Now, after the text or after the combination, we could realize that these observables has been combined. Each item emitting has been combined. And guys, it's not going to emit only, but it doesn't finish with the first observable, then it's come to the second observable. No, it emits them one by one. So it emits one, let's say nuts, then it can emit 20. Then it passes to the function, it combines them, then goes to Kevin, it emits also 30 in that order. So as a result, this is what we are having: Nat 20, and Kevin had a score 30, and Roxanne has a score 50, and Cindy had a score 60. Okay, so for instance, there's a lot of arguments and a lot of talkings around zip operators. And for zip operators, some people have a notion that it helps in parallelism. Okay, helps to run your load in a parallel manner. Some too also has a view that it helps you to run the load in a sequential manner. And guys, they are all true, they are all correct, depending on how you treat them. So let's try to mimic something like an API call. So we know that API call, when I have an API call, it sometimes delays. You see, if you are to run this, it doesn't waste time. It's within some seconds and it is done running. But then if we are to mimic an API call, we know it can delay for some time. So let's try to mimic an API call. For you to mimic an API call, what we can do is we can map the item and delay the emission. So we grab the emitted item, the single emitted item, then we try to delay its emission. So we can use our map function. I have treated map in my previous tutorials. If you don't have this understanding, you could go back into my tutorials and you will see or watch the map tutorials and you'll be better off or good to go. So now let's use the map. So what we are trying to do is we try to delay its emission by, let's say, 2 seconds. So we could delay the thread dot sleep 2 seconds. That's 2000 milliseconds exactly. So then let's try to return our s, that's the item. Now with this, we could realize that this is executed sequentially. How do we know this? Let's try to print the we can also try to print the thread it is running on. So how do we do it? We can do system.out.print, and then we can grab the thread dot current thread dot get name. Okay, so with this, I think this will help us to get the thread it is running on. And let's try to make it let's say x. Okay, I want to do something like this so that I think we can know the differences. Okay, so let's do same for the second item. Let's try to map it so that we can get an individual item. Okay, so here too we do the same thing. Then we return, here we have to use integer. Then we return the integer. Okay, now, and let's also try to do say in the function where it combines the whole function. Let's try to, you just want to know the thread that it is working on and see if it is having the same, it is working on the same thread, so that it can ease off with our understanding. So we have our integer, and I think okay, so let me say final results. So what we can do, something like final results. I think it is fine. Final result. Okay, so let's run this and see what we get. Okay, so NAT is running on main thread, and let's see, it took 9 seconds. Okay, it took 9 seconds to get our result through the applied function, and we could see that NAT is running. I mean, the first observable is running on the main thread. The Calvin, Roxanne, all of them, they are all running on the main thread. So actually, they are all running on the main thread, and the final results, I mean, the function also running on the main thread. Okay, so in this case, you could say that these are sequential because it is just making of use of only one thread. So it try to get the observable from the first item, from the first observable. Then when it gets emitted, then it will wait for the second observable to also emit the first item in that order. So it's actually, they are waiting for each other, so it is sequential. It's because of it making use of only one thread. Okay, and this is the sequential part of the explanation. Then how could, because if you run this, you could see that it takes some time. It takes some time. Okay, but how do we try to let it run parallelly in a parallel mode? How do we try to let it do that? So what we could do is, this is an observable. So all that we can do is we can try to subscribe. You can try to subscribe or do the work. Subscribe means doing the work. So do the work on a new thread. So shadow does, let's say, new thread. We can create a new thread for this. Now, if you are to run this, you will see that these items are being worked on the new thread. Okay, it is being worked on the new thread. And what actually says, Mostly sometimes I think I've talked about this in my last tutorials. Let's try to copy this off. Let's try to copy this off. Okay. Okay. So zip. Okay. So with a zip, mm, yeah. So let's try to run this again and see what we get. Okay. Let's try to run this and see what we are going to get from here. So it is running. Give some seconds and it will be done running. Okay. So we get Nat 20, Kevin, Roxanne 20. So let's try to use the log to print this. Let's try to use the log to print this. So that we can get the thread. I mean, what the actual result is what we are getting, but we just want to know the thread it is running on. So let's do this. Let's do this with a thread, the log. Okay, so let's run it again one more time. One more time. To be done running, just installing. Just installing. Okay. 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 So this is what we are getting, and I think the format is not actually bad, but we can see. So as I said, we are trying to know, we are trying to work off this item or this load in a parallel mode. So we are making use of different threads to work on this. So right now, as we have shown you working how the load can be executed sequentially, and now with the parallel mode, we could realize that from the logs we could realize that first of all, the 20, 30, these were operated on. These were operated on the main thread. Okay, this item, it was operated on the main thread because we have not subscribed it on a different thread, so it is using the main thread as the default. And now the NAT was actually also subscribed on the different thread called rs new thread scheduler 1-1. So that's the main thread. So we could realize that because this is not sequential and it is actually in parallel mode, this is being operated on a different thread. Okay, that one we understand. So what we could see that with the second observable, even though the actual behavior is supposed to, if it was, let's say, sequential, we could realize that as we saw that, let's say, the first observable will emit the first item not, and the second observable will also emit the first item 20 sequentially, but now it is on a different thread, like in a parallel mode. So this is wasting time. The first observable is wasting time because it is, each observable is being delayed by 2 seconds. As a result, this, they don't know each other. This threads don't know each other. So as a result, the second observable was done emitting the observable. That's what we could realize here. So you see 20 came, 30 came, 50 came, 60 came, and it paused. Then it was waiting for its companion, I mean its partner from the first observable. Now it wait for the first observable to emit. So when the first observable has emitted, NAT, okay, this NAT emitted, and after that, after NAT was emitted, then it will just take the first item and the NAT and come and apply it in our function here. Okay, and the second item Kevin also came. Then it came with the next item, which is on the row 30, and so forth and so on. So let me try to remove the locks so that I think explanation could come clearer. So let me run this and let's go through it one more time again. Okay, so this is on our output. We are getting NAT 20, Kevin 20, and it is simple and it doesn't waste time. So guys, so no matter how the behavior is, even when the first observable is done executed before the second observable, at the end of the day, we are fully 100% sure that we are going to get each of the items one by one, and we can apply our function to it, as I said. And one of the I mean one this is one of the importance of zip operators. Okay, and the second important I could also get from this operator is that it can take a number of observables to be emitted, I mean to be jointed, as compared to some of the combining operators. We will come back to it in my subsequent tutorials. Look forward to that. So what I mean is, we could have something like this observable. Sorry. We could have something like this observable. So with this, we are using zip iterable. So it takes an array list, or you can pass any a collection, array list, all these iterable, and all the data structures that extend or implement iterable can be passed in here. And what it does is it takes a number of observables. I'm just duplicating this. So right now we have 2 observables in here, and it can take as much as a lot. And at the end of the day, the apply function will give us, instead of, it can say A, B, C, D, as we could see from here. From here, we could see that we are zipping them, but it takes it look at the parameters that we are passing as our argument, or yes, argument. Then we depending on the number of arguments, then we can know which of the functions, type of the function that we could use. Okay, so but with this, we don't need that. All that we need is, if it is a list, it will give us the object, an array of that object. So in your function here, apply function here, as I said, this is only 2. So I know it's 0 and 1. I'm sure of that. I'm not going to get any 9 point array index out of bounds exception. I'm not going to get that, because I know it is only 2 items coming here. But for example, let's say we have, let's say, 4 or 6 items. If you have 4 or 6 items, let me try to copy this. How many items? More. Okay, this item, and now, okay, so we have the zip. Yes. So now, for example, we have this number of scores. how many scores you can get from here. We have a lot, okay, a lot of scores. Okay, so we have a lot of scores in here. So this number, so these are the scores that we have, and I think you can count it. When we should, if we are to run this, these are the list of our observables, and in here, in the apply function, I know that it is going to give me the array of the observable, okay, the items emitted by this observable. I could grab them here. Then what I can do is I just, for each, in this function, apply function, I just try to write my function and just try to use what I just want to use it for, okay, just that. But here I'm just trying to concatenate them with just a string concatenation, just like that. Then I'll just print them off. So if we are to run this, let's run this and see what we are going to get. Okay, so it is done running. We have 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So that's the number. Okay, so that's the number of items, the observables that we have here. So this is another important feature of zip operator that I love about this a lot. So depend on the number of observables that you just want to combine. You just use a zip iterable and you just write just a simple function and it will do it for you. Just like that, okay? Just like that. So guys, this is, let me try to get my subscription so that at the end of the day, when I'm done, all that I can do is I just try to dispose it. I just dispose it after use. So dispose, okay, must be called for you to unsubscribe your observer. Okay, so guys, so this is what I wanted to treat in this tutorial about zip. So try to work your hands on it and you see the importance of zip operators. And guys, if you haven't subscribed to this tutorial, try to do and subscribe to these tutorials or this channel so that anytime I release a new video, and I can assure you of a lot of things are in the pipeline. A lot of things are in the pipeline, and for you not to miss that, try to subscribe and try to click on the bell icon so that immediately it is being released, you can be the first bird to watch it and enjoy, guys. So this is the end of this part. Next time we try and talk about combine. We try to talk about combine, latest, join, merge, okay, and then all these are operators that I'll be considering to teach in my subsequent videos. Try and subscribe so that you can stay tuned. Thank you for joining me and have a happy coding.